right, y'all, this is the second half of the lesson for today. We're going to talk about more linear equations. Specifically, we're going to look at point slope form, and then we'll also look at standard form. So if you are in Algebra 2 CP, you won't see standard form too terribly much, but if you're in Honors Algebra 2, you definitely need to make sure you understand like the standard form. So we're going to start off by looking at point slope form. It says here the essential understanding: the slopes of two lines in the same plane indicate how the lines are related. So given the slope and the y-intercept, you can write the equation of a line in slope-intercept form, and you can also write it in point slope form. So as I talked about in the last video, okay, the name says it all. What the name says is what you have to have. So point slope form mentions that you have to have a point and you have to have the slope. Those are the two things you have to have: a point and the slope. If you do not have a point and you do not have the slope, then do not use point slope form. Okay? But we're going to see, even if you're only given 2 points, can you still write it in point slope form? Absolutely. But first, we're going to start off real easy, and we're going to write an equation given a point and the slope, just to make sure you're following along with us. So I have a line that passes through the point -5, 2, and it has a slope of 3/5. What is the equation of the line? So I'm given point and the slope, so I'm going to use point slope. And they've kind of worked this one out for us already. So I'm going to use my equation y minus y1 equals m times x minus x1. And all I'm going to do is substitute into my equation. So the -5 would be my x1, the 2 would be my y1, and then this would be my m. So you can see here, using that information, we have y minus 2 equals 3/5 times x minus the -5. And you can see they put everything in parentheses. It looks so beautiful. Anytime you substitute in, got to use those parentheses. And then here, all they did was change that minus a negative to a plus positive. And we have our final equation in point slope form. Easy enough. They gave us all the tools to be successful. So there's nothing really to that one. On the next one, we're going to do the same thing. We're going to start from scratch, so here we go. So I am given a point, and I am given my slope. So I'm going to use point slope form. Y minus y1 equals m times x minus x1. So again, if you want to take a second and label some things, the x1 and the y1 and the m, you're more than welcome to. So we would have y minus a -1 is equal to -3 times x minus 7. So from here, let's change that minus a negative to plus a positive. So we have y plus 1 is equal to -3, parentheses, x minus 7. This is point slope form of our equation. Now, let me take this just a little baby step further. What if I wanted you to write your equation in slope-intercept form? What would we do here? If I wanted to take point slope form and change it to slope-intercept form, what would I need to do? Well, the first thing I need to do is to distribute that -3. So I would have y plus 1 is equal to -3x plus 21, because the -3 times -7 is positive 21. And then all I would have to do is subtract the 1. Because remember, with slope-intercept form, we got to get the y by itself. So we would have y equals -3x plus 20. Again, that's if I wanted slope-intercept form. They didn't specify here, so I could have just left it. All right. On problem number 2, this is where it gets a little different. It says here, a line passes through the point 3, 2, and 5, 8. What is the equation of a line in point slope form? So they want us to write an equation in point slope form. That's really important, right? Well, what do you have to have with point slope form? You need to have a point and you need to have the slope. Does it say anywhere in the problem what our slope is? It sure doesn't. So I'm going to have to go back to what we just learned in 2.3, and I'm going to have to find the slope between these 2 points. It all builds. Isn't that so nice? All right, so in order to find the slope, I have to do y2 minus y1 over x2 minus x1. So here I'm going to do 8 minus 2 over 5 minus 3. That gives me 6 over 2, so my slope is 3. So now I have my slope and I have a point. It doesn't matter which point you pick, so I'm going to choose this one. Why did I choose that one? Because it's smaller numbers. All right, so I'm going to go ahead and use my point slope form, y minus y1 equals m times x minus x1, and I'm going to substitute in. So here we go. I would have y minus 2 equals 3 times x minus 3. And I am done. Why am I done here? Because the question asked for point slope form. If they asked for slope intercept form, I would have to then distribute. But it asked for it in point slope form, so I am done. So on this next one, if you want to go ahead and try and see if you can figure it out on your own, you're more than welcome to. If you want to keep following along with me, just let's keep it going. So we're going to do the same thing here on problem A. A line passes through the point -5, 0, and 0, 7. What is the equation in point slope form? So first things first, I have to find the slope. y2 minus y1 over x2 minus x1. So again, if you want to label some things, you are encouraged and more than welcome to. So here we go. We have 7 minus 0 over 0 minus -5. So be careful here, guys, with that minus negative. That's plus positive. So that gives me 7 over 5, which is my slope. Again, doesn't matter which point you use for when you're plugging in point slope form. It really doesn't. I'm going to choose this one this time, and I'll tell you why. It doesn't have a negative in there. So I'm just making my life easier. Y minus y1 equals m times x minus x1. So I get y minus 7 is equal to my 7/5, because again, that's my slope. And then I have x minus 0. There is my equation in point slope form. On part B, this is a reasoning question. It says, what is another equation in point slope form from the line with the same points? Well, instead of using the 0, 7 point, you could have used the -5, 0 point. They would still come out to be the same if you get them in slope intercept form. But yeah, it really doesn't matter which point you use, though. All right, with standard form. Again, this is something that we use in the upper level math. If you want to try it and see if you can follow along, I encourage everybody to participate with this. But if you're feeling super, super overwhelmed, we totally understand. And if you want to fast forward through this part, you are more than welcome to. But for honors, you are required to learn this. So standard form is another type of linear equation that you need to be able to recognize. Another form of the equation of a line is standard form, in which the sum of the x and the y are set equal to a constant. Okay? When possible, you write the coefficients of x and y and the constant term as integers. Now, this right here is standard form. ax plus by is equal to c. Okay? ax plus by is equal to c. So, really important, x and y are on the same side. Okay? Second important thing, a, b, and c are always integers. So what do I mean when I say integers? There are no fractions, okay, as those coefficients. There are no fractions whatsoever. Third thing, and this is a particular thing that we do. This isn't in the textbook. This is just like a mathematician, like good practice of habit. the A value is always positive. Okay. So 3 things. X and Y are on the same side. All the coefficients are integers. And the A value, that first coefficient, is always positive. Okay. So let's take a look at problem number 3 here. What is an equation of a line y equals 3/4 x minus 5 in standard form? Use integer coefficients. So the first thing that they did was they moved the x value to the other side. That was our first step. X and y have to be on the same side. Now, in order to get rid of the fraction, they multiplied everything by that denominator of 4. So everything got multiplied by the 4. So now you can see they have their equation, negative 3x plus 4y is equal to negative 20. Now, again, the textbook does not emphasize this, however, we do here at Bearden. So I need you to make sure that that A value is positive. Well, how do I do that? Well, I'm going to multiply by negative 1 on each side. So my final equation would be 3x minus 4y is equal to 20. This is my standard form of my equation. Okay. Now, on this next one, you notice that you have decimals. Okay? That should not intimidate you, though. All right, so let's tackle this together. What I'm going to do first is get that x value to the other side. So I have negative 9.1x plus y is equal to 3.6. Now, we can kind of, for lack of a better expression, kill 2 birds with 1 stone here. I notice that that a value is negative, so I can multiply all the sides by something negative. But what is going to make that decimal go away? How can I make 9.1 turn into an actual integer number that doesn't have a decimal per se anymore? I can multiply both sides by negative 10. Because by multiplying by 10, it's going to move that decimal to the back, and I end up with the following equation. 91x minus 10y is equal to negative 36. You might not have known to do the 10 right off the bat, but hopefully after seeing me do it, you're like, oh, yeah, okay, yeah. So again, 3 things. X and y have to be on the same side. They all have to be integer coefficients, and then your a value has to be positive. So what we have done so far is we have looked at 3 new forms of 3 different forms of equations. 2 of them were new today. 1 of them we learned previously. We know that slope-intercept form. This form is used when you know the slope and the y-intercept. So again, the y-intercept being 0, b. Point-slope form you have to use when you are given a point and a slope, or when you're given 2 points, because then you can find the slope. And then standard form. Now, I know what some of y'all are thinking. You're like, why did we just learn standard form? Like, what's the point of standard form? Okay, standard form can help you quickly determine the x and y intercepts. And this will be really helpful for the non-calculator portion of your test. So, on problem number 4, I'm going to show you how this works. What are the intercepts of 3x plus 5y is equal to 15? If you want to find the y-intercept, right? We talked about this a little earlier. That's the point 0, b. In order to find the y-intercept, you plug in 0 for x. So, in my standard form equation right here, I'm going to take the 0 and plug it in for x. So then that gives me 3 times 0 plus 5y is equal to 15. Well, 5y equals 15, then y is 3. So my y-intercept is the point 0, 3. And that's what I have right here. Same thing when you're finding the x-intercept, it's just flipped. So instead of having 0, b, we would have some value for x, 0. So what would I do here? I would plug in 0 for y. So again, same standard equation, except now I plug in 0 for y and I solve. So I get 3x plus 5 times 0 equals 15. 3x equals 15. That means x equals 5. So I would also have the point 5, 0. And it only takes 2 points to graph a line. Oop, that was kind of bad. I was way off. There we go. It only takes 2 points to make a line, so I am done graphing. Again, this is very helpful when you are able to recognize why do we have standard form. Oh, it helps me graph very quickly. Very, very quickly. All right, let's see if y'all can try this one on your own. If you get stuck, go ahead and press play so you can watch me go through this. Or if you're like, nope, Money, I'm completely lost still, then stay right here. Just follow along. So I have 2x minus 4y is equal to 8. If I want to find the y-intercept, we plug in 0 for x. All right? To find the y-intercept, we plug in 0 for x. So we have 2 times 0 minus 4y is equal to 8. That gives me negative 4y is equal to 8. Divide by negative 4. That gives me y is equal to negative 2. So I would have the point 0, negative 2. That's my y-intercept. For my x-intercept, we plug in 0 for y, and we solve. So we would have 2x minus 4 times 0 is equal to 8. So that gives me 2x equals 8. Divide both sides by 2. X is equal to 4. So that means I have the point 4, 0. A lot of our students will get x and y intercepts confused and how to write them. So we strongly encourage you to take the time to know the difference now. And then you could plot those 2 points and graph your line. It says to graph it, but I obviously ran out of room, so you can graph that on your own. All right. Though I think this is the last thing we're going to talk about today. Parallel lines and perpendicular lines. So we actually learned this in Algebra 1, and you went over this in geometry. And so we're hitting it again in Algebra 2. The slopes of parallel lines are equal, okay? So for instance, if the red equation has a slope of, let's call that like 3/4. If this has a slope of 3/4, then the blue equation also has a slope of 3/4, okay? It's the exact same. Now, when you have perpendicular lines, it says here the slopes of perpendicular lines are negative reciprocals, okay? You might have heard us say opposite reciprocals. It's the same thing, okay? So for example, let's say this blue line here has a slope of, I don't know, like let's say 5/3. It looks pretty steep. Let's say 5/3. Well, then that means the blue line would have a slope of negative 3/5. So the opposite came from the opposite sign. The reciprocal means you flipped the fraction. So what was 5/3 now becomes 3/5. And again, it's opposite as well. So let's try some out here. On problem number 6, it says, what's the equation of each line in the slope-intercept form? Okay. Now, I do want to emphasize here, all students in Algebra 2 need to know this topic, so make sure you are watching this. Okay, make sure you're watching. Everybody should be watching this part. So it says, what's the equation of each line in slope-intercept form? It wants us to find a line parallel. Ooh, as I'm reading, I am annotating. The line parallel. So in my mind, automatically, I know they're going to have the same slope. So let's look at our equation here. Y equals 6x minus 2. I know that the 6 is my slope. That's going to stay the same. So my slope is still 6. So what I'm going to do now is write the new equation with this slope and this point. So if I'm going to have a point and a slope, I have to use point-slope form. Y minus y1 equals m times x minus x1. How did I know to use this equation? Because what I was given. So I'm going to say y minus negative 3 is equal to 6 times x minus 1. I'm going to change the minus negative to plus positive. So I get y plus 3 is equal to 6 times x minus 1. And in the directions, if I remember, it says, what's the equation of a line in slope-intercept form? So just like before, I knew what was coming. We have to go ahead and multiply this out. So I get y plus 3. Here we go. Y plus 3 is equal to 6x minus 6. And now I just have to move the 3 over. So I get y is equal to 6x minus 9. This is my final equation. I know I went through that pretty quickly, but if you need to replay that or work out the next one with me, you are more than welcome to. I thought I had some practice problems, so hopefully that'll be good. So I'll work this next one out with you, and then y'all are going to do the next two on the next slide. So here we go. Same thing, except now we have perpendicular. So again, in my mind, that tells me it's not the same slope. It's going to be opposite of that negative, so positive, and then reciprocal of 4. The reciprocal of 4 is 1/4, because remember, you've always been told, like, oh, imagine it's divided by 1. All right, and then we're going to do the same thing. I have a point, and I have my slope, so I'm going to use point slope. So I have here y minus 5 is equal to 1/4 times x minus 8. And again, I can't leave that as my answer because they said they want it in slope-intercept form. So I have to distribute. This is where it gets fun with fractions. So we have y minus 5 is equal to 1/4 x minus. What is 1/4 of 8? So like if you have 8 things and you wanted to divide them into 4s, you would only have 2. So now the last thing I'm going to do is add the 5. And we get the equation y equals 1/4 x plus 3. So parallel, you keep the same slope. Perpendicular, that's when you change it. And that takes us to the next slide where you're going to try these two on your own. Parallel, one's perpendicular. Now, on part A, you should notice something's going on with that equation. It is not in slope-intercept form. So you're going to have to take a second and get it in slope-intercept form in order to figure out what your slope actually is. So I'm going to move the negative 4x over to the other side, divide by 2. So y is equal to negative 2x plus 7. This is my equation in slope-intercept form, but guys, this is not my final answer. I had to do that in order to figure out what the slope even is. So now I found what the slope was, and now I have my other point at 4, negative 2. So now I can go ahead and do my y minus y1 equals m times x minus x1. So I get y minus negative 2 is equal to negative 2. Why did it stay the same? Because it's parallel. X minus 4. So right here, this becomes plus 2. So y plus 2 is equal to negative 2 times x minus 4. And I have to distribute because it wants it back in slope-intercept form. So I got to come up here. And I'm going to say y plus 2 is equal to negative 2x plus 8. Where did I get plus 8 from? Negative 2 times negative 4 gives me positive 8. So then subtract the 2. So this equation is y equals negative 2x plus 6. Okay. Last one, next one. Perpendicular to the equation y equals 2/3 x. So my slope is going to be opposite, that makes it negative, reciprocal, 3/2. So I have y minus y1 equals m times x minus x1. So that gives me y minus 6 is equal to negative 3/2 times x minus 0. I'm going to go ahead and distribute. So I get y minus 6 is equal to negative 3/2 x. Anything times 0 is just 0. So this one's really nice. Finish up here with y equals negative 3/2 x plus 6. So here is my final answer. And we are done with 2.4. Now, again, if you needed help or you need to maybe go back and watch something, please do and ask us during office hours. If you want some more help before you move on to your lesson quiz, you are more than welcome to work these out, and I would be happy to help check your answers if you want to send them to me on Remind. But from here, you can do the lesson quiz, the lesson little check thing, homework thing, and then you can start on your homework after that. If you have any questions, though, please don't hesitate to reach out.